to 10 or 15 different ways we can think about how love interacts with the word, companion or something like that. These large language models can think in 1,000-dimensional space.
Yes.
And it can think about how every word interacts with every other word and with
kind of simultaneously
all at the same time in triplets.
Right.
And it's just a different kind of intelligence, which is really exciting.
And this is where, obviously there's a lot of people who are excited about the research in this space of, understanding, explainable AI. But there's nothing to say in many ways that the type of intelligence, the deductions that are made by a model will be explainable in a way that a human could really understand it. And that might suggest, putting some, let's say, artificial limits on how the models operate and what they can.
Welcome back to the Ignite podcast. Today, we're delighted to have Dr. Matt Welsh on the program. I saw his recent talk at CS50 on large language models. Thought it was really interesting. Wanted to have him on the program. He's, got an impressive background in computer science from Cornell, Berkeley, where I went to grad school. He's been a professor, been at startups, working on his own stealth thing. Matt, thank you so much for coming on.
Yeah, thanks for having me.
Would love to get an intro from you for the audience.
Yeah, so I've been working in the AI space since around 2019. This was before language models, before ChatGPT. I was an engineering director at Google for about 9 years, working on the Chrome mobile team, and left to join a small company here in Seattle called XNOR.AI, which was building highly efficient machine vision models that ran on.
Remember those guys?
Yeah, they built the vision model that ran on the Wise camera, these very inexpensive internet cameras, and we got acquired by Apple. So I had the pleasure of joining Apple for a while. Decided at that point I really wanted to be back in startup land. So then I went on to OctoML, which has since renamed to OctoAI, because I guess AI is cooler than ML, and was head of engineering at OctoML.
Back then, I think Octo, I remember those guys as well when I was at AWS, and I nobody said AI back then because everybody's like, no, it's not AI, it's ML. And so everybody's embracing, 7-8 years ago, everybody embraced ML as the term. And
AI was a bad word or something, or it
you couldn't say it. It's like, it's not really AI. Yeah.
And now it's flipped the other way. ML's kind of old and boring, and AI is the hot new thing. So I was there for a couple of years, and then I left to start my own company. Started Fixie.ai, which is still going strong. They're building out real-time voice capabilities using language models, and recently left Fixie to start a new venture, which is still in stealth. And, we'll see where that goes.
Exciting time. So tell us, what a large language model is. Let's just start at the beginning for anybody who's brand new to this stuff, and why is it so scalable and revolutionary and came out of nowhere?
Yeah, I mean, it's amazing technology that, of course, is everywhere. In the old days of AI, back in the ancient history, people learned that,
like the early 2010s now, or
no. I mean, I'm talking like the 70s and 80s when people started experimenting with neural networks. And interestingly, when I was in high school in the early 90s, I was building a neural network that ran on my PC that could detect the sparks of speech of words in a sentence, so it could label words with verb, noun, adjective. But somewhere along the way, people figured out that you could take this neural network technology and make a really big version of it, and then just throw lots of text at it and train it to basically do one thing, which is, given some input text, the beginning of a sentence, my dog is laying on the, and then you ask the model, what's the next word most likely to be?
Given the context window that, all the tokens, all the words that you just occurred before it.
Exactly. And it'll say more than likely something like floor or, whatever else. Now, that doesn't sound that impressive. And I think the thing that surprised a lot of people is, this idea of just auto-completing the next word. Well, that doesn't sound at all interesting. However, what seems to be happening with these models is whatever internal state they have learned in order to do that very well has allowed them to effectively learn some kind of higher order reasoning, we think. There's a lot of debate on this point, but the idea that I can ask something like ChatGPT to write me an essay or to write a business proposal or to analyze a big spreadsheet and give me insight.
Yeah.
All of those things, it's still the same.
And there's not a lot of recursion built into the models, as I understand it. It's just basically all one shot, a word prediction. And so the very fact that it can say, hey, write me a marketing materials for blah blah, and you feed it like some stuff, it does it in one shot. It writes this essay. It's as if you just typed it all out yourself at superhuman speed, obviously, and you never made a single correction, which is pretty wild. But
that's wild. Yeah. So this technology has really taken off because people have found out that it's just so powerful. But originally, the intention and the idea was not necessarily to build general purpose AI. This was just a thing for text completion or maybe translation between languages or something else. And what we've seemed to have invented is something far more powerful.
Right. And if you think about the structure of the brain and how neurons kind of interact to have an emergent quality of consciousness and intelligence, it seems to reason that if you had a substrate that you've repeated trillions of times, and you had some sort of feedback mechanism, you should get some sort of emergent property out of a system like that.
Yeah, I mean, that was always the hope or the thought. I think people had been doing very large neural networks for other tasks like machine vision for a long time with, I would say, decent but not amazing results. And I think something in the way that the language models were designed, this transformer architecture is what we call it, is the way in which it's wired up internally and the mathematics happening internally seems to have unlocked this much more powerful set of capabilities that really were not anticipated even by the people who invented it.
Yeah. Where do you think the limits are? We keep getting larger and larger parameter sizes. We seem to be jumping it looks like about an order of magnitude every 6 to 12 months. Do you see that going forever, or is this some asymptote? And in the universe, in the system of reality that we live in, there's always an asymptote. So I wonder where that asymptote is here on this architecture.
We haven't reached it yet. So the naive answer is, let's just keep making these models larger and larger and larger. And, the earliest models were, on the order of a few billion parameters. And now we're getting models of hundreds of billions or even trillions of parameters. Every jump in the size of the model allows it to encode more and more information and seems to result in a much substantial improvement on the model's reasoning ability and all the capabilities and the things it can do. So the question is, where is the limit, right? We haven't started to see it flatten out yet. I think a lot of people are concerned around the idea that we don't have enough training data to enrich larger and larger models. That if you end up in a situation where you're just feeding it the same data over and over and over again, there's a point where you do get diminishing returns. And so the question is, will that happen? We don't know.
I think you made this point in your talk, though, which was really interesting. I think it was in your talk. Maybe it was in another talk. I saw your talk, months ago at this point. But, the human brain takes in so much data already, right? It's like we're already taking, as humans, between all our senses, I don't know how many petabytes of data that it's just flowing through our biology. And so, I mean, you can make a case that there's tons of data, and we haven't even really woken up these AIs. I mean, really kind of probably in the bottom of the first inning, to use a baseball analogy, of the amount of data we can unlock when you start, feeding all the Tesla driving data into it. We start, feeding all the, Google has a huge head start with all the YouTube data and stuff like that. But, you start having robots and sensors and cameras everywhere, sensing, smelling, tasting, feeling, touching. You might see, a whole shitload more.
I think that's probably right. I think the challenge, of course, is that tension between, there's a bunch of data out there that was never really intended for ingestion by an AI training models. And so people are rightfully concerned, YouTubers and podcasters and others might be concerned that this stuff I put out there on the internet is now going to get used for this other purpose. And of course,
you actually go to theignitepodcast.com. We have one of our portfolio companies, Podcast.AI. They could take an episode and you can have a conversation with the episode, and then you can have a conversation with me. They can take my voice and make it sound this AI.
Yes. Right.
So, it's like
so maybe that's what I'm
impersonation.
Doing right now.
And I only have 20 episodes uploaded. I mean, I have another 60 episodes I could upload to make the data and training even better. But you could foresee a future where maybe I'm not even doing podcast episodes anymore. It's this AI persona of myself.
Mm-hmm, mm-hmm. And podcasting is an interesting one because I know a lot of creators are very concerned around their content being used to generate like exactly this. I mean, you're saying this is great, do this. I think there will be many podcasters who want that. There's going to be others who say, oh my gosh, this is my livelihood. This is my product, my brand or whatever. And they're concerned around that data. So I think that's going to be a tension, but eventually my expectation is that sometime I'm kind of guessing the next 5 years, we're going to be, there's a lot of debate about what's meant by general purpose AI, what's meant by, an AI that can do pretty much anything. I don't think that's important. I mean, it is an important thing for humanity, but I don't think that's the most important next milestone. I think the next milestone that we're going to find that's really compelling is the ability of these models to automate things, to do work, not just, and yes, it's already doing work in the sense of like, yes, it can summarize my email or whatever, but I mean, solve problems, figure out what the next steps are, call out to external systems, all that kind of stuff.
Yeah.
And that is where we're going to see a major, major change in terms of how people interact with technology.
Yeah. And you're already starting to see that. I mean, agentic workflows and platforms, and we have some companies in our portfolio that Paradigm's one that just came out of YC, companies like that are basically wiring up all this stuff. And, OpenAI is not going to sit still and just let that happen. They're going to try to be the platform of choice. And same with Gemini at Google, probably Bedrock at Amazon and Anthropic. And they're all racing towards this general purpose. I can see and do things automatically for you like an assistant would. And have this kind of ambient intelligence that sort of just watches you work and just does stuff for you and anticipates your needs. And we're very close. 5 years, could be a year or two before we start seeing
it could happen sooner. I think it depends on your use case. And I mean, certainly in narrow domains, I mean, I use ChatGPT and Copilot and all these things every single day, nonstop, to do all kinds of things. So we're already seeing that transformation happen. I think the difference will be when I can really let it loose and say, for example, hey, I'm planning a trip to Boston in July. Can you please go ahead and, book all my flights or set up my hotel or set up meetings or reach out to people for me and connect me with the right set of folks that I want to meet with. I think that kind of, let's say, personal assistant capability is going to take a while to get it to the point where it's really great. We're going to see a bunch of kind of maybe cheesier versions of that, but those cheesy versions are okay too. I mean, I'm reminded of the early, Apple IIe, Apple IIc kind of computers.
Yeah.
And, you look back on
CompuServe and Prodigy, like early 90s internet things.
Exactly. Yeah. And it kind of sucked compared to what we have today, but it was still so good and useful in its own way. I think that ended up being, something that pointed the way to the future, that those early versions of it were still incredibly useful and incredibly beneficial to people, even though they had all these limitations.
Yeah. It's something I think about as an investor, is it's easy to be too early to the market. It's hard to be too late, I think. Like you look at like Google, it was the 17th search engine. You look at Facebook, it was like the 7th social network. And so as an investor, I try not to think about, I just invested in something like that last year or 2 years ago. I try to think, why is this going to succeed even more so than what I invested in previously? And I try not to have this like sunk cost bias in my investment philosophy, which is like, I don't care what I invested in last year. I mean, yes, I do care. I want it to be successful, but I'm also
But you
thinking
don't
of,
need to anchor on that. And
I don't need to anchor on
as,
it.
yeah, and as the technology it improves, things get better and better. I mean, there's a reason Google was so successful as a search engine is that we had learned so much more by the time Larry and Sergey developed Google at Stanford that about how to do that well.
Yeah.
Whereas the early versions of search engines were quite crude in the algorithmic approach that they used. And so I think that, being later is actually beneficial if you have a technology that actually does something substantive. I do think Facebook is an interesting one because I was around Harvard in the early days of Facebook, and so I saw that emerge, as it happened. It started out at Harvard only,
Right.
and I was one of the first, I don't know, a couple hundred people on Facebook. I think one of the things that made it really successful was the super strong network effect around keeping it limited to people in your college campus. Initially with Facebook, you could not friend somebody who was not at your own campus.
Yeah, that's smart.
And I think that was super smart because it created these clusters, these tight clusters in the social graph, rather than me just going out there and finding random people in Brazil or whatever to connect with.
Yeah, I connected with somebody down in Austin, and I live, 2,000 miles away. Who cares?
Right.
Yeah, we would call that the geographic marketplace go-to-market strategy, something like that. Which is like, okay, well, you're going to go capture just Austin, and then you're going to move on. And Facebook's masterstroke, as you said, was like, no, we're just going to go campus. We're just going to nail the campuses, and then eventually that was nationwide, and they opened it. I remember when they opened it up to everyone else. I don't even know if I had my UW email still.
Right.
But yeah, so I think about that as an investor, and getting into the right companies. So, what are some of your other takeaways from giving that talk? What were some of the questions, the insightful questions you got from students, and some surprises that you've seen in the industry since then? Because it was 3 months ago now.
Yeah, this talk that I've given has started to kind of morph a little bit, and I'm doing another iteration of it now. Next week, I'm giving the talk at the Craft Conference in Budapest, and
my wife's Hungarian. We go there all the time. So
great. So it's one of those things where my thinking around this has really evolved a lot, primarily because I've been doing more and more building using the language model as kind of the core computational engine. We talked about podcasts. One of the things that I was playing with was taking in a transcript of a podcast and then using the language model to tell me what are the names, the identities of the speakers in the transcript, just based on contextual information within the transcript. And it turns out the language models just do a great job at that.
Wow.
Right? That it's so easy. You just say, here's a transcript, tell me who the speakers are. And it does, it labels them. And it's not always
without
right,
the name explicitly being in the transcript.
Well, I mean, it usually is, because if you're talking to somebody, I mean, you said my name and you said your own name. And so a lot of that anchoring can happen much in the same way as if you and I were just listening to the podcast. I don't know who's this speaker, that speaker, but you introduce the person, and therefore I can anchor against that. But the point of this is, if I think kind of from a conventional computer science perspective, the conventional computer science perspective was always, well, there has to be an algorithm, and this algorithm needs to be written down, ideally in some kind of pseudocode form or something, that can then be studied at a like around its complexity, and for what properties does this algorithm have, and is it correct or not? All those things, that's kind of conventional CS. But when you think about asking a language model, here's a transcript for a podcast, please give me a JSON object that identifies the speakers, I don't think anyone could write down an algorithm for that. What's the algorithm that does that?
Now, in a classical coding sense, like in Python or something? Yeah.
Right. Yes, you could say, okay, so first you tokenize the input text, and then you feed it to this thing, and you multiply by these matrices. I mean, yes, of course there's an algorithm, but that's not useful. That's not like the kind of, so
it is a deterministic solution for everything in the universe, but it's probably so hard to code up some of them that effectively
so we can't study it. Like a computer scientist can only study things that can be expressed in this way. So in some sense, we can't study it. So, a conventional CS argument would be, well, therefore it's sort of not useful. It's just some, random thing that's happening.
Sounds like a philosopher, Sounds like more like, yeah.
I can't reason about it, therefore I don't care about it. But, really we have this new use of computing that we don't have the formal tools or even the language to reason about. And that's scary. I mean, it's exciting, but it's scary because I do think the thing that everybody is really worried about, and I worry about it, everybody worries about it, is like, how reliable are these things going to be?
Yeah.
You can't think of them as this mechanistic, like I wrote the code that runs in the Boeing, aircraft, flight control system or whatever. And so I can make statements about what it does and what it doesn't do under certain conditions. These language models are genuinely a black box. So what do you do?
Yeah. Well, that's interesting. They behave a little bit more like a conscious being, right? Where they're kind of stochastic and unpredictable, and sometimes they're late for work, and sometimes they get things wrong and misremember things. And so, I think it's the right tool for the right job, right? I don't think you'd ever, to your point, ever want to put Chat GPT 4.0 in charge of the Max 737 flight controls.
But
maybe
some future version you might, some future version you might. I mean, imagine having a virtual aircraft pilot. And...
You said something even more interesting, which is like the computer science now is there's almost a schism happening. It's kind of like what happens in economics, right? Where that's not something I can model with classical economic theory, and so it's something else. Maybe it's behavioral economics. And and maybe the same. Maybe it's behavioral computer science is what's emerging here.
That's a very good observation. I like that analogy with economics. Right?
Yeah, it's kind of like this new version of computer science that we have to grapple with now. That will have a bunch of outsiders who are not classically trained computer scientists thinking about. And the first semblance of that is prompt engineers, right? I'm really good at prompting this intelligent thing to do what I want. But in the future, it might be other things, other forms of computer sciencey stuff that's not quite computer science.
That's right. And you start to, and I think there's going to be a new science that needs to emerge around how do you best train these models to do what you want, right? Just yesterday, in fact, I was working with my son who's in high school on trying to train a version of GPT-4 that can translate between English and Lushootseed, which is the Coast Salish language of the native peoples of the Pacific Northwest, one of the languages. And he's very interested in this language, and there's a whole community of people that speak it, but there's very few online resources for it. And so what he did was there's a dictionary, a big fat book that happens to have been turned into an online searchable database of Lushootseed phrases and their English translation. Okay, so it's just a correspondence. It's, did he come last week? And then the Lushootseed phrase for that. He extracted all of those examples, about 5,000 of them. And we have been experimenting with how do we get, a GPT style model to do a good job understanding and translating for this language. And we don't know. I mean, there's so many things to try, right? There's not really a science around this, I would say, because unlike, the way that conventional transformer training is done, we don't have this massive data set of, petabytes of data to throw at the model to teach it how to speak this language. We only have these 5,000 examples or something. And so there's a science that needs to emerge around how do you do that training? And I think of it a little bit like how we study early childhood education. There's so much known about best practices for how do you teach children how to do things and what's the right kind of, environment to create in a classroom setting and all those things. And I don't think that this is going to be that dissimilar. Yeah. Ultimately, we're going to have models that have the sort of the raw computational power to do almost anything. The question is, how do we effectively guide them or steer them in the right direction?
Right. Yeah, sort of the the fine tuning, as it were, or hey, here's a novel problem that wasn't in your data set originally, which is what you're describing. You already, hey, by the way, you already translate really well because basically it's compressing everything down to a matrix space, right? Which is really fascinating. The 3 blue, 1 brown videos on YouTube are just really great.
Those are the best description of this stuff that I've seen is the 3 blue, 1 brown videos. Definitely go watch those.
Yeah. Shout out to that guy. Just makes excellent visual videos on all science and math, and computer science topics. And what's really interesting about these models is how many dimensions of space they think in at a time, which is why the intelligence is so alien. We can only think in 7 plus or minus 2 typically is what psychologists think. So even if it's a 10 or 15 different ways we can think about how love interacts with the word companion or something like that.
Right.
These large language models can think in 1,000-dimensional space.
Yes.
And it can think about how every word interacts with every other word, and with
kind of simultaneously
all at the same time in triplets.
And
it's just a different kind of intelligence, which is really exciting.
And this is where, obviously there's a lot of people who are excited about the research in this space of, understanding, explainable AI. But there's nothing to say in many ways that the type of intelligence, the deductions that are made by a model will be explainable in a way that a human could really understand it. And that might suggest, putting some, let's say, artificial limits on how the models operate and what they can do. Because, say you gave a future AI system a complete write-up of somebody's medical history, and it said, I have a 98.3%, prediction confidence that this person is going to have a heart attack in the next 3 years, right? Well, of course, this is bad news for the person involved. They're going to want to know what's involved in that decision-making process. But that decision-making process...
Don't worry about it. I have trillions of parameters and weights and biases. And
I mean, that's right.
I got to figure it out.
There's no way to prove.
Like
there's no way to guarantee that it will be able to explain that. Let's just say for sake of argument that it's right. The problem there is now we're like, oh gosh, we have effectively a higher intelligence that we can't explain how it operates. And do we use such a thing or not? Is our society ready for that?
Well, I think if it is super intelligent, which I think it will be, as we keep 10xing the compute and parameters every year. You could just say, hey, explain it to me like I'm a human. Like I'm just a regular, classic, above average intelligence human. Like, everything about me, right? So like, look at my LinkedIn profile and explain it to somebody like that.
Right.
And they'll be like, okay, here. Yeah, I'll explain it to you. So like, I'm looking at your resting heart rate, your heart rate variability. I'm looking at your blood pressure and, all these things and probably 5 other things we're not even thinking about. And, I know everything you ate. I know your weight, how it fluctuates. I know how you sleep because I'm looking at your Fitbit data. And, it turns out I built this classical logistical regression model using all this data. And you didn't even know that I did that. It's just like sitting in some, parameter, like deep in the model or series of parameters. And I just predicted that. And here's the output of that. And
but that may not be satisfying, I think, is my point, which is right. If I can't draw a connection, if I can't say, well, here's why I think that, it's because here are the you could say there's these million variables involved,
right?
And here are all the weights, and here's how I combine them together to come up with this prediction. You're still just complex. Staring at a sheet full of numbers. You're not going, well, do I trust this? Versus being able to, like what a medical doctor today should be able to do is point back to, established medical practice or to research papers or whatever, that there's some explainability there. So anyway, my point is we're going to be at this point where the AI is more useful and correct than we are comfortable with in our society. And so how do we wrestle with that?
I've dealt with this. I've dealt with this in my career. Like I worked at Rocket Fuel, a tech unicorn, using AI, evaluating 150 billion bid requests a day, using very, scaled logistical regression models, more or less. But that was always the number one complaint from our customers. Is like, great, the performance is 3x better anywhere else, but can you teach me why?
Right.
And so it took us years of digging into those models and trying to visualize it and figure it out. And how do we communicate what the model is doing? And these were logistical regression models with maybe dozens of weights and biases. We're talking about models with trillions of parameters, probably, to your point, developing submodels within itself of millions of data points. And it's hard to explain. It's like explaining like what we're doing to ants and mice. Very difficult, right? Like, how do I explain, how I got into this Tesla and it's driving itself down the road to a mouse that's just like trying to find a piece of cheese.
Well, I feel that way when I get in my Tesla and it's driving itself. I do worry a lot about this. It freaks me out because I never know. Is it going to pay attention to that person, about to cross the street?
What's so funny about this? I hate how it sits in somebody's blind spot.
Oh, yeah.
And you're from Seattle. I'm from Seattle. So we're very like cautious, defensive drivers. Like that's the culture of Seattle.
Right.
And that's how I grew up. My grandfather like drilled it into me, And so like the Tesla is like, it's programmed by a bunch of California drivers. And so it's really aggressive and it kind of sits like right on, you have to say no, back up off people. Don't sit in there, be more casual. Don't like bob and weave in traffic. And then all else, don't sit in somebody's blind spot going 75 miles an hour. What are you doing? You're just kind of sitting there.
Well, that's very true. I would love to see how the Tesla driving model works in India or something where, the way people drive there is vastly different. There needs to be a regional setting, I bet.
So a big topic of your talk was how programming changes with AI and large language models. What's your vision for the future over the next 3 to 5 years? Not like long term, because it's hard to predict anything beyond 5 years now, I think. But how do you see? Yeah.
I mean, a lot of people have been talking about things like Copilot and automatic code generation, and that's really exciting. And I use that all the time. And there's going to be a lot of improvements to that. I think the place where I'm much more interested in is how can we use the model in place of writing code. And so that example of the podcast, turning the transcript and labeling the speakers in the transcript, like I couldn't write that as code. I wouldn't ask the model to generate code to do that. That doesn't make any sense. So it unlocks new kinds of programming that we haven't had before. And so the question there is, all right, what are the kind of tools, or I'm going to say languages, that we want to use around that? Do I want it to be formal? Today, it's really informal. You talked about prompt engineering. If I ask the model how to do something for me in English versus French versus, Swahili, I'm probably going to get different results, and that should be a concern. And so is there going to be a need for a way to formally express what you want out of the model in a really unambiguous way, or to work with the model when there is ambiguity, so that, people can actually collaborate and build applications or programs that use that capability? And I've seen there's been a couple of startups working in this space that's kind of exciting, building new kind of graphical user interfaces for how do you build applications with prompts and conventional code kind of intermingled. But, today what we're doing is so crude. We're basically just jamming, text strings into Python and and calling out to some API, and that's how we do things. But I don't think that's going to be the right way to program using these models as I think of the model as really a new kind of computer that we're going to end up wanting to give tasks to it. It needs to have memory. It needs to have state. And so I don't know how that's going to evolve. That's something that I'm doing a lot of experimenting with myself. I do think it's going to look pretty different than, writing a program in the conventional way. Is it a new programming language? Do we come up with a variant of English that has some formal semantics that we can reason about? Those things exist, by the way. Philosophers and linguists have done a lot of work in that well before the age of AI, to unambiguously encode things like, legal statutes and so forth in a language that is unambiguous in the way that you interpret it. So those are the kinds of things that I'm really excited about right now, is to see where that ends up going.
Well, it's almost as if you collaborate with this new form of intelligence, this new form of compute, in a way that you would collaborate with anyone else.
Right.
Hey, when an email comes in, please evaluate it against, all my other emails, all the other responses I've ever made, what you know about this person, what you know about me, how I've responded to people like this in the past in this situation, and draft an email. It's almost like you're communicating to your executive assistant.
Right.
I just had somebody on the podcast, another VC, who was talking about his dictaphone that he had back in the 90s with the secretary.
Yeah,
right. Which is kind of like 20, 30 years ago. Some people were already living in the future, which is like I dictate things to do to my assistant.
Yes.
And they go do them. And now we're all going to have an assistant that's just sitting there waiting and willing and able to just, do stuff for us. And we'll just be dictating stuff. And I'm waiting for this. I keep, using keyboard shortcuts and stuff like that. I'm excited to get the desktop app that kind of just watches me work all day and just forms a very large context window of all the things. And maybe in the background, it's kind of like compressing that memory, like the way that when we go to sleep, our brains compress the memories and down into the neural, architectures of our brain. And I'm imagining that we're going to have to develop those kinds of systems, right, for AI, where it's kind of like, I just absorbed a petabyte of info about your day. That's too much to store. That's ridiculous. But I can compress it now down into a gig or 100 megs or something of really useful strings and snippets and stuff, so that I can now reference that in a context window for the future.
That's right.
Something like that.
I think that's exactly right. And I think the challenge for companies wanting to work in this space is there's a tension between building things that are really useful in some like narrow domains, and like, for example, for like a sales, person doing sales calls, or a lawyer, or a doctor, versus wanting to solve the broader set of problems.
That's in business. It's always that in business, right? It's bundling, unbundling, as James Barksdale. It's a horizontal platform shift: mobile, cloud, internet, Apple IIe, PC. And then somebody comes on and goes, nope, we're going to like compress that into this vertical and go really, really deep with this use case. And that's where we like to play, the application layer verticalized stuff. Especially, like, I've been in AI for a long time. It's really hard to compete at the horizontal layer and get into the next OpenAI as a little VC that I am. I can't just go like get into the next OpenAI. I don't have that network. I don't know Sam Altman and stuff. Like I'm just not going to get into those things. And maybe I missed out on $1 trillion opportunity, but there's lots of billion and $10 billion opportunities you've never heard of every cycle, right? Thousands, hundreds created every year. And so that's where we like to play at Team Ignite. We like to kind of dive into the verticalized stuff. And we have, you a bunch of verticals. I think I have an AI vertical play in each of those verticals already.
Right.
And I'll probably have many more in each of those, because I don't know if I'm too early or if I'm too, like, I can't be too late, but I'm probably too early on a lot of those already.
And I think it makes sense to go vertical, especially where we are now, as a starting point, at least, because you learn the most by really engaging deeply with a certain kind of customer. If your customer is anyone, it's very hard to learn substantive things as a small team, right?
Yeah.
And so trying to build the general purpose personal assistant that lives on your PC or something is a hard thing to do. I mean, you can do it, you can try, but I do think that going deep with, software engineers or lawyers or whatever, and then, ideally by doing that, you're going to learn things that generalize to different domains.
Yeah.
And it's not just going to be highly specialized. Yes, you're going to have to go and solve a lot of gnarly problems that are specific to, say, the legal profession. But hopefully, 70% or more of the work that you do is actually things that will ultimately generalize beyond that.
Yeah, I love that. Yeah, you put it well. Let's wrap up with a rapid fire.
Sounds good.
Okay, so what is the most surprising insight about large language models from your research?
I think really the fact that they can solve problems. I think to me that blows my mind. That you can give them a problem and it can pick it apart and take it step by step and come back with a solution. That to me it was utterly surprising when I saw that the first time.
This natural recursion and reasoning that could happen inside, like a human doing it. Like, let me break that problem down and think about it step by step. And I remember back at the 3.5 days or 3.0 days, you used to have to tell it to do that.
Yeah.
And now it just does it.
Now it just does that.
Now, yeah.
That's right.
What's a key piece of advice you have for developers starting with large language models today? Like maybe they're playing with the API layer kind of stuff.
Yeah, I would say, at least for now, my recommendation is just go with whatever the best, biggest model is that you can experiment with, and not spend a lot of time trying to cut costs or be clever about the performance. Because I think, as we've seen, you go with a model that may be a little too expensive or a little too
Yeah.
big, and you're not quite sure. You might think it might be overkill. Well, 3 months from now or 6 months from now, another version will come out that's, half the cost and 5x the speeds. Don't hold yourself back
I love this.
by using limited models, I think.
I love this. And this is exactly what, when we evaluate a startup, we'll ask what the margin is. We'll dig into the kind of the unit costs. So often, they're using the latest, greatest model, and it's very expensive to inference. And, on the margin, it's only 20% margin, which is not typical SaaS margin. But I know it'll get 90% cheaper
Right.
In the next, like you said, 6 to 12 months.
Mm-hmm.
And so I'm okay with that. I know in 12
That's
months,
right.
by the time they have, some PMF and scalability, that all of a sudden they'll have much higher margins. What's the hardest concept in AI you've had to explain?
Gosh, the transformer architecture itself is the thing that even I wrestle with, trying to explain to people how that works. Then you mentioned the 3 blue, 1 brown model videos. I think that those are really great expository around how this stuff works. And actually watching those, even though I've read all the papers and I have been dealing with this stuff quite a lot, when I saw those videos, I went, now I understood something I didn't before. So I do think that it's been very hard to kind of unravel an intuition around how this stuff works.
I love those videos. I'll just sit on the couch and geek out and just watch those videos because I'm such a visual learner, and I think a lot of us are. I think when I see the way he illustrates it with these 3D graphics, I'm like, yeah, I get it. I get what it's doing and how the data is flowing. And what's your favorite project you've worked on in your career, or maybe at Google or any other company?
Gosh, that's a hard one to answer because I've been lucky to work on so many. I'll mention one. Back when I was at Harvard, I was fortunate to work with a group of geophysicists that were studying volcanoes in Ecuador, and we developed these little battery-powered wireless sensors that we went and hacked through the jungle literally to go deploy on the side of these volcanoes in Ecuador, and got to witness close up some extremely violent volcanic activity, and collected a bunch of data, and wrote some really interesting papers around all the things that we learned. But I think that one probably stands out to me as something that I learned the most, and I think the key lesson for me was going super deep with this, very narrow vertical, if you will.
Yeah. Very
allowed
literally
me to learn things.
Deep into a volcano.
Exactly.
Deep into the jungle.
Learn things that no one else could learn, right?
Yeah.
All these other people working in the space didn't have that opportunity. And so I think that was really worth it.
That's so cool. What's a tool you wish existed for large language model development right now?
Gosh, I mean, I think the doing the quick and dirty benchmarking of how do different models operate with different tasks is quite challenging still. Like it's still a lot of just stuff you got to glue together just to try out. Somebody says, oh yeah, this new Llama 3 thing came out. It's like, great. Okay. Now I'm going to have to go and, spend an afternoon sort of bolting it into my system and trying it out. It would be nice if there are several sort of demo sites like this, but just have
kind of unit testing, regression testing, and very simple kind of like, okay, if I plug this in, here's all the tests I needed to run to make sure that this works better.
That's right. And it can just pick the best model for me based on the results of those tests or something like that.
Yeah, some auto ML kind of stuff from 10 years ago. But auto LLM.
Auto LLM selection or something, or federation or whatever.
Yeah, here's the list of inputs and outputs you're expecting, from all the conversations I observed in your customer service center. Right. And now I'm going to go just plug this into LangChain and run a multivariate regression against every possible combo and just tell you exactly the right. Yeah, I totally get it. What's a sci-fi technology you wish was real?
Gosh, that's a very good question. I do think getting to the point of a brain-computer interface that is really rich is something that I think I believe will probably happen in my lifetime. I would hope.
Yeah.
But, the idea of really deeply integrating the power of computation with the power of human cognition without us having to go through this keyboard and screen barrier that we have, right?
Yeah.
To me, that would
Or even voice.
unlock a
Voice
lot of
will
things.
like be 3 times faster, probably 3 to 5 times
Right.
faster,
Exactly.
but not as fast as thought.
That's right.
And then eventually, as Kurzweil would say, like we're all just living up here in the cloud anyway, right?
I won't go that far, but yes,
Yeah.
something like that.
His new book comes out in June. I can't wait.
Oh, okay.
Yeah.
I should read that.
Yeah. Singularity is nearer, June 25th. It's on the calendar. I pre-ordered the Kindle and the hardcover. Because I read that back in 2006 when I was washing out of Wall Street. I was trying to figure out what to do with my life, and I was always a sci-fi nerd growing up. And I was like, I think technology is going to like change everything. I better get on that train. You know?
Guess it remains to be seen whether it will.
Yeah, exactly. Well, this is a great conversation. Thanks so much for coming on the program. We'll have to have you back when there's a big, AI announcement or GPT 5.0 or something like that, or when you're when you come out of stealth.
Sounds good. Thanks very much, Brian.
Thanks, Matt.
Have a good one.